Okay, question 4 of the exam. The question is related to graphing kinematic quantities. That was sort of the context of the question, and specifically determining the instantaneous velocity from a position time curve. So we're looking for the magnitude of the object's velocity at t equals 10 seconds, and to get the velocity at a particular instant in time, you must draw a tangent line to the position time curve. So this is it is a parabola, and that means that the velocity is constantly changing. So it has a different value at every single instant. But to find the velocity at t equals 10, we've got to draw a tangent line and then determine the value of the slope of that particular tangent line. So 10 is at this sort of point here. So I'll draw my tangent line as best as I can. And it's pretty close to these values, so let's work this out. Let's see, sort of, if I drop this line down here, these seem to be 10, 11, 12, 13, and 14. That goes all the way to 0. So my run, it will be 14 seconds. My rise looks like it goes from 40 to 80. So let's see if that works, which of these answers this is closest to. So the velocity by definition is delta x over delta t, the slope of this line. So the rise looks to be 40 meters. The base looks to be 14 seconds. And if I work this out, should be very close to 3. 2.9. So that would definitely be, there's no answer in the sense these numbers are varied quite a bit. So that's definitely closest to choice B, with some adjustment in the tangent lines and how accurately they're drawn. But this is a long way from 0.5, and just to make a note, 7 is in a way is a distractor. That 7 is very close to the average velocity. So at 10 seconds the object has traveled almost 70 meters, but that would be, in a sense, looking for the slope of the line almost from 0, which is very different than the actual velocity at t equals 10. So the average velocity from 0 to 10, so the average for the time interval from t equals 0 to t equals 10, which is not the question in hand, but an important thing to point out, I think, would be approximately equal to 70 meters. Again, it doesn't start exactly at 0, but again, approximating it to 10 seconds, so it would be approximately 7 meters per second. But that's the average, so it's sort of, this object is starting out with a steeper slope than this blue line that I've drawn. So it starts out moving faster than the tree, and eventually slows down to 3 meters per second at 10 seconds, and that's what the question is asking. What is the velocity at t equals 10 seconds? And that would be approximately 3 meters per second, given that that is the slope of the tangent line drawn at that instant in time.